Hi, welcome to our channel of IGNOU audiobooks, Indira Gandhi National Open University, School of Vocational Education and Training, SOVET, Diploma in Modern Office Practice, DMOP, BSSI 01 to Computer Skills, Block-1 Fundamental of Computer, Unit-1 Computer Organization, 1.1 Objective. In this unit, we introduce you to the organization structure of computer. After reading this unit, you will be able to draw organization of computer, to define structure of microprocessor, to define functions of different components of computer, i.e. input, processing, memory, and output units, and to understand the classification of computer on the basis of its work efficiency. 1.2 Computer. Computer can be defined as electronic machine performing calculation at high speed and capable of collecting, storing, analyzing and manipulating large volume of data. Thus, computer is an instrument which makes calculation convenient. Tables, scales and mechanical instruments such as abacus, slide rule, log tables are in use for a long time for making measurement and calculation easy. But these instruments are not described as computer. The computer may be defined that it is an electronic machine which executes a pre-recorded sets instructions. The pre-recorded sets of instructions are known as programs. Analysis and calculation on computers are done in the manner as directed by programs. Thus, computer can be characterized with two features: automated calculation and programmability. The first, calculation machine with these characteristics, was designed in 1887. Charles Babbage designed the first fully programmable mechanical computer and named it as Analytical Engine. Alan Turing is widely regarded as the father of the modern computer. He conceptualized the Turing machine. The Time magazine listed Alan Turing as one of 100 most influential people of the 20th century. 1.3 Binary number. Every electronic system has two possible states, either on or off. Similarly, computer, an electronic device, also recognizes these two states. Instructions and data to computer are mediated. It is through only these two states, on and off. Computers work on the base of peculiar number system with a base of 2 is known as binary number system. There are two possible values of single digit in the binary number system, i.e. 0 or 1. Computer understands and stores instructions and data as a series of 0 and 1 in the binary form. Every instruction and data fed by human in the natural language is automatically converted into binary format. Computer stores and process data in the binary form. Outcome of processed data, which is also in binary form, is converted back into natural languages understood by human. The decimal system is the most widely used number system by us for computation. The base of the decimal number system is 10, i.e. a single digit in the decimal number system can have any of the 10 possible values, i.e. 0, 1, 2.9. The base of a number system is also called its radix. The radix of decimal number system is 10. Similarly, binary number has the radix value of 2, with 0 and 1 as possible values. Radix of a number system is used to understand value of numbers under that number system. For example, the value of number 425.74 of decimal number system can be explained as is equal to 4 times 10 square, 2 times 10 power 1, 5 times 10 power 0, 7 times 10 power minus 1, 4 times 10 power minus 2 is equal to 425. 0.70.04. The same procedure is used to know value of numbers indicated in the binary number system. For example, value of binary number 1,10,11,101.00101 can be explained as 1 times 2 powers 7, 1 times 2 powers 6, 0x 2 powers 5, 1 times 2 powers 4, 1 times 2 powers 3, 1 times 2 powers 2, 0x 2 powers 1. 1 times 2 powers 0 0 x 2 powers minus 1 0 x 2 powers minus 2 1 times 2 powers minus 3 0 x 2 powers minus 4 1 times 2 powers 5 is equal to 128 64 16 841.125.03125 is equal to 21.15625. 221.15625 is decimal number equivalent of the binary number 1,10,11,101.00101. You have understood the conversion of binary number into decimal number. Now, we will do the reverse and understand the mechanism of conversion of decimal number into binary form. Suppose we have to convert a number d of the decimal number system into the binary form. Divide the numbered by 2, we obtain quotient q and remainder a. The remainder a is the least significant digit of the binary number. Now divide the quotient q by 2 and obtained remainder will be digit for the second position, second most significant digital of the binary number, and quotient is used to get next significant number in the similar fashion as stated above. Repeat this process and keep on getting the next significant digit of binary number until the quotient becomes 0. This procedure is explained with the help of an example for conversion of decimal number 25 into binary form. Thus, the binary equivalent of the decimal number 25 is 11001. The single digit of the binary number system is known as bit and a combination of 8 bits is known as byte. Thus, a byte can represent any of 28 is equal to 256 combinations of 0 and 1. Thus, possible values of a binary number can be understood as power of 2 to powers n, where 2 is radix of binary number, n is number of bits in the number. Similarly, the decimal number system is explained as power of 10. 10 is the radix of decimal number system. For example, a decimal number with 2 digits can have one of 100 possible values, 0 to 99. This is the reason why capacity of memory card installed in your computer, car, or mobile phone is always reflected as power of 2. For example, 1 megabyte memory card is equivalent to 1,048,576 bytes to powers 10, and 1 gigabyte card is equivalent to 1,073,741,824 bytes to powers 20. You may have understood the conversion of the decimal number into the binary number and vice versa. Now we will understand how computer handles conversion of alphabets and special characters such as at, etc. into the binary form. There are standard code specifications to represent alphabets and special characters in the binary form. The ASCII, American Standard Code of Information Interchange, is universally accepted code specification to represent the binary equivalent of alphabets, numbers and symbols. However, the IBM-based PCs use the EBCDIC, Extended Binary Coded Decimal Information Code, specifications in place of the ASCII code to represent alphabets, numbers and symbols in the binary form. The ASCII specification was introduced in 1960s and EBCDIC code was specified in 1964. The ASCII code specification is based on 7-bit number where EBCDIC coding specification is based on 8 bits per character. 10 is added at the extreme left end of each number in the ASCII code to make its length 8 bits. For example, A is represented as 01000001, B letter is represented as 01000010, and number 5 is represented as 00110101 in the ASCII code specification. The leftmost digit, 8th bit, is always 0 in the ASCII code. The EBCDIC code specification for the same characters, i.e. A, B, and 5 are 11000001, 1,100,010 and 1,11,11,001 respectively. Thus, computer converts every data and instruction fed to it in natural language into binary form with the help of ASCII or EBCDIC code specifications. Data is stored, processed and analyzed in this form. The processed data and results in the binary form are converted back in a form understood by other computer or human beings with the help of these standard code specifications. 1.4 Organization of computer. We can understand the organization of computer by our skills of solving problems. When we solve a problem, we need inputs and instructions which support in solving the problems. The supportive information may be embedded in problems or obtained from surrounding or other sources. We act in problems according to input data. Context, basic rules that are applicable and our experience in solving similar kind of problems in the past. Basic rules and experience helpful in solving of problems are memorized by our brain. The solution of problems is adopts reflected through our actions, cues, physical movements. A writing. Computer also adopts the similar approach in solving problems. A computer gets data and instructions which are supportive in solving problems from human or other machines. Computer processes data and solves problems as per predefined procedure and rules set in computer. The predefined procedures are sets of instructions arranged in a sequence and are termed as programs. Programs are stored in the memory of computer. Outcomes of data processing and solutions of problems are conveyed to human or other computer. Thus, the problem-solving skills of computer and human are alike. The basic components of a computer system are input, processor, memory and output units. The input component of the computer gets data and instructions from human, other computers are from surrounding as sensed by electronic sensors. Data and instructions can be input to computer automatically or manually. Computer has a processing unit to solve problems and inbuilt memory to store data, basic instructions, rules and programs needed to solve problems. It has output unit to display or communicate results of data processed or problem solved in the forms understandable by human or other computers or machines. 1.4.1 Input. Computer can take instructions and data either from human or other computers or storage devices. Input devices get data and instructions from human in natural languages and convert it into language understood by computer, i.e. binary language. You can input data and instructions with the help of keyboard, mouse, microphone, camera, CD-ROM, storage taps, pen driver, scanner, etc. Input devices differ according to the nature of inputs supported by these devices. For example, keyboard is used to feed alphanumeric information, scanner to capture images of papers, microphone to feed audio signals and camera to capture image. Some of these devices are more appropriate in particular contexts. For example, keyboard, mouse, and scanner are the popular input devices in the office environment. Similarly, audio-video synthesizers, camera, microphone and webcam are the popular input devices for preparation of multimedia. The functioning of popular input devices in office environment will be discussed in detail in the next unit. 1.4.2 Processing Unit. The processing unit manipulates data, solves problems and executes instructions fed by users in a predefined manner. It functions like a human brain. The processing unit of computer is also known as the central process unit, CPU, or microprocessor. Small computers have only one microprocessor. Powerful computers can have more than one microprocessor to run in parallel to achieve high calculation and data processing efficiency. The Pentium 4 microprocessor, manufactured by the Intel Corporation, is the latest and most popular CPU for personal computers, PC. The PC is most popular computer at homes, small organizations and schools. Its characteristic will be explained shortly. 1.4.3 Storage unit. Living things require memory to retain their knowledge and experience to perform day-to-day tasks. Similarly, computer also needs memory to retain data, instructions and programs. These information are needed during the processing of data and solving of problems. No data processing takes place in the memory unit. It just makes available data and instructions needed by the CPU at the right time. Memories inside computer are in different size and data retrieval storage speed. Computer stores the specific memory depending on importance of that data in processing, frequency of uses of that data and volume of data being stored. The data needed frequently by the CPU is stored close to the CPU on a fast speed memory. This memory is known as the primary memory or main memory. This memory is situated inside computer and it is in the form of integrated chip (IC). It is also called as chip memory. Random access memory (RAM) and read-only memory (ROM) are examples of the primary memory. The functioning of RAM and ROM will be explained in the next unit. Data, which is not needed frequently by the processing unit, is stored on low-cost and slow memory. This memory is known as secondary memory. Whenever processor needs certain information from the secondary memory, computer first transfers desired data from secondary memory to primary memory on temporary basis. A copy of data will be always there on the secondary memory. The processing unit takes these data from the primary memory and processes it inside the microprocessor. Computer transfers updated and useful information back to the secondary memory through primary memory after the completion of operations on the data. The transfer of data between primary and secondary memories is automatically done by computer without intervention of users. Primary memory is temporary in nature and data are vanished from the primary memory, RAM, with switching off computer. You should successfully close all the running applications before shutting down computer so that important data and information can be transferred safely from primary memory to secondary memory. Differences between primary memory and secondary memory are explained below. Primary memory, expensive and fast, in the form of chips, closely connected to the processor. Storage and retrieval of data is in the real-time mode, i.e. data is stored or retrieved within certain time limit regardless of location of data in the memory. Whole data and instructions, which are under process, examples are RAM and ROM, and temporary in nature. Data is vanished from RAM once application is stopped or computer is switched off. Secondary memory do not directly communicate with processing unit. Data are first transfers to main memory and then to processor, permanent in nature, economical and slow in speed, used to store large volume of information. Examples are hard disk, CD-ROM, pen, drive and magnetic tap. The BIOS stands for Basic Input-Output System. It is stored in a ROM memory situated on the motherboard. The motherboard is the main electronic circuit plate inside a computer and has vital electronic components of the computer. The BIOS has essential information about the configuration of computer. When you turn on computer, the BIOS chip wakes up the computer. It performs basic operations, checks hardware components and have control over the computer before operating system takes over the control of computer. The BIOS have mechanism of identifying frequently occurring errors in hardware components of computer and signal them in the form of beeps. The storage capacity of memory devices is represented in kilobyte, kilobyte, megabyte, MB, and gigabyte, GB. 1 kilobyte, kilobyte is equivalent to about 1000 bytes, 1024 or 2 powers 10. 1 megabyte, megabyte is equivalent to about 1,000,000,000 bytes 1,048,576 or 2 powers 20, 1 gigabyte, is equivalent to about 10,000,000,000 bytes, 1 billion, 1,073,741,824 or 2 powers 30. Computer can run multiple programs at a time and share primary memory with all the running programs. The data storage capacity of the primary memory is limited as these memories are very expensive. When you run multiple programs, each program stores certain information in the primary memory. The requirement of the primary memory goes beyond the storage capacity of primary memory. Computer can enhance the capacity of primary memory through the virtual memory. Virtual memory is especially reserved space on the secondary memory, hard disk, which is used as the primary memory. 1.4.4 Output unit. Output unit is used to convey outcomes of the data processed, problems solved, or instructions executed by the computer. Monitor, speaker, and printer are the popular output devices in the office environment. The information can be conveyed by displaying or printing results information on monitor or papers respectively. Sometime output of one computer can act as input for other computers or electronic devices. The input and output devices are abbreviated as I/O devices. Output in the form of text, pictures, and graphs can be presented over monitor or paper. Output displayed over monitor are known as soft output. As display on the monitor is temporary in nature. New visuals override the existing visuals. You have only the latest visual. Users can have frequent look of intermediate results or document while typing over monitor without wastage of paper. Monitor has added features to extend visual supports to disabled peoples. Monitor can use bright and contrast colors to make display visible to visually impaired people. Output on the paper are known as hard output as it is permanent in nature. It also enjoys high mobility. People can carry paper-based outputs with them while they are out of office or home. Paper-based output is easy to read as people are habitual of reading books and papers in printed form. Output of computer may also be in the form of sound and visual. Computer uses speaker to play audio stream. 1.5 bus. Different components of computer organization exchange instructions and data with each other. These components exchange information through buses. Buses are like highway. Use it to transfer data and instruction within computer. The process of transfer of data among components of a computer is a complicated task as components exchange and process data at different speeds. For example, the CPU can receive data at GHz speed and I/O devices can receive data at MHz. Thus, CPU sends data at GHz to I/O devices, but I/O devices do not have competency to receive data at that speed. This mismatch may lead to loss of data, blockage of precious time of CPU in exchanging of data with slow devices. Thus, mismatch in the speed of transfer of data in components of computer hampers the processing speed of computer. Controllers over the bus manage the transfer of data among devices with mismatch in speed of transfer of data. Controller over the buses coordinate and control transfer of data between devices. When a high-speed device sends data to slow device, it transfers data to bus controller and starts execution of pending tasks. It is now responsibility of the controller to manage transfer of data from controller to slow speed receiver. Once the entire data get transferred to slow device, controller inform high-speed render about successful transfer of data. Similarly, when high-speed device demands data from slow device, the high-speed device instructs controller to get a copy of data from the slow device and it engages its pending tests. Controller transfers the entire data from slow-speed device and inform high-speed device to get the data from controller. The high-speed device takes a break from task under process and gets data from the controller at high speed and resumes the execution of pending instructions. Buses are classified as address bus, data bus, and control bus on the basis of the nature of the data, which are being carried by these buses. Data buses are bidirectional because data flows to or from CPU and main memory. It carries data in both the directions. These buses can carry data and instructions. Address buses are unidirectional because address code is carried from CPU to memory. Control bus carries the sets of timing signals. These timing signals are used to synchronize activities of various components of computer. Control bus is bidirectional. Numbers of lines in buses to communicate address, control, data, or instruction depend up the microprocessor embedded inside computer. 1.6 Central Processing Unit. Central Processing Unit (CPU) is a chip or set of chips which enable computer to process data and execute instructions given by users. The CPU is also known as microprocessor. It is the brain of computer. Every CPU has inbuilt clock that emits. These pulses are called cycles of CPU. Number of cycles in a unit time, second, is the speed of the CPU. People usually assume that speed of CPU specifies number of instructions can be executed by that CPU in the unit time. However, some instructions require multiple cycles for execution. For example, when you instruct computer to sort 10 numbers, then computer makes multiple passes over the given data to sort numbers. In first cycle, it selects highest number and places it at the first place. Computer repeats this process with remaining of the numbers, selects the highest among the remaining of the unsorted numbers and takes it out and places it at next position in the sorted data. This process continues till there is unsorted data. Thus, computer takes 9 cycles to sort 10 numbers. Microprocessor needs additional instructions and data to execute instructions issued by users. For example, when you instruct computer to calculate 43, 4 power 3, computer goes to instruction set and understands procedure to calculate power. The instruction set explains computer to multiple 4, 3 times to get value of the 43. When computer performs first multiplication 4x4, it needs memory to store results of 4 times 4, i.e. 16 on temporary basis. In next cycle, computer multiplies 16 to 4 to get value of 43. Thus, CPU needs memory to store instructions and data helpful in making calculations and decisions and to store intermediate results of calculations on temporary basis. The speed of execution of instructions depends on the complexity in instructions, number of cycles need to execute instructions, speed of CPU, requirements of additional data, and instructions from the memory and speed of the memory. However, high cycle speed of CPU assures fast execution of the instructions. For example, suppose a computer has a CPU of 3 GHz speed but data and steps needed for the execution of instructions are retrieved from the memory at a speed of 10 MHz speed. Thus, the execution speed of the CPU drops from 3 GHz to 10 MHz. Most of the time, CPU stays idle, waiting for data from memory. We have already discussed role of bus controller in dealing with mismatch in speed of transfer and process of data of devices and in improving efficacy of CPU. Still, slow devices hamper the speed of the CPU. Every CPU consists of arithmetic unit, logical unit, control unit, and memory components. In summary, arithmetic unit is used to do arithmetic calculations, logical unit is used to make logical decisions, and control unit is used to control and synchronize operations of various components of the CPU and manage the exchange of information in various components of CPU. The control unit of the CPU monitors the function of memory unit, arithmetic unit, and logical unit of the CPU. Like a human brain, control unit of CPU assigns tasks to different components of CPU and coordinates functions among these units. The dotted line in the figure 1 reflects the controlling mechanism of computer. The data communication across different components of computer is reflected with solid line with arrows at the ends of each line. These arrows indicate direction of flow of data. For example, there is a solid line connecting input unit and memory, with arrow heading away from input unit to memory. The arrow direction indicates that data always move from input unit to memory unit. There is solid line connecting control unit and memory with arrows heading to control unit. It indicates that the flow of data between memory unit and control unit is unidirectional, i.e., memory unit supplies data to control unit. The arrows, heading in opposite directions at the opposite ends of a line, reflect that data moves in both the direction, bidirectional. For example, the flow of data between memory to arithmetical and logical units of the CPU is bidirectional. The main circuit board of computer, where CPU and other vital components of computer are installed, is called the motherboard of the computer. Apart from CPU, a motherboard has RAM, ROM memories, buses and slots to connect other internal and external devices such as monitor, hard disk, CD-ROM, etc. All internal components of computer are directly connected to the motherboard. All components of computer are interconnected and exchange information with the help of communication cables, buses and jumpers. 1.7 USB, Universal Serial Bus, is a specification used to exchange information between external device and computer. It was developed by Ajay Bhatt in 1994 while working for the Intel Corporation. Now, computer peripherals such as mouse, keyboard, printer, storage media and pen drive are connected to computer through USB ports. The USB-based external devices can be plugged in or removed while computer is still running. Without switching off the computer, operating system automatically detects USB-based devices within seconds after plug-in and switch on the corresponding software utilities. USB-compatible external devices have symbol on connecting code as shown in figure. Pen drives are popular mass storage devices based on USB port. These are also known as the flash drives. Flash drive is very compact in size. It can transfer data at high speed. Now, all models of mobile phones have provision of USB connectivity. Mobile phones can be easily connected with computer and other electronic devices having provision of USB connectivity. The USB ports are also used to supply electricity and charge batteries of electronic devices and mobile phones. The USB-based charger can charge devices even when computer is switched off. Computer experts stipulated that USB ports would replace serial and parallel communication ports of computer. Serial and parallel communication ports are used to connect external devices to computer and exchange information with these devices. These ports are usually situated on the backside of the computer cabinet. Now, personal computers and laptops available in market have only USB ports to offer connectivity with external devices. These computers are without serial and parallel ports. The USB 1.0 specification was introduced in 1996. The maximum data transfer rate of this specification is 12 megabits per second. The USB 2.0 specification was released in April 2000. This specification can achieve the maximum speed of 480 megabits per second. The USB 3.0 specification is the latest specification released in 2008. The maximum cable length in the USB 2.0 is 5 meters. Thus, USB-based devices cannot be placed beyond this range. There are several types of USB connectors when classified on the basis of speed of data transfer and physical shape of connector. The USB connectors are classified as Type A, Type B, Mini B, Micro UB and Micro B. USB connectors of Type A specification are the oldest and USB connectors of micro specifications are the latest development in this direction. The latest specifications ensure fast, reliable and error-free transmission of data. Before connecting any peripherals to computer, examine what kind of USB connectivity is desired by the device and shape of connector. The peripheral can be connected only in USB slot of computer, physical shape with USB connector of peripheral. Also ensure that the USB slot in computer also support the specification of USB communication of the peripheral, USB 1.0, USB 2.0 or USB 3.0, otherwise mismatch in specification will slow down data exchange speed with peripherals. People claim that USB-based devices can be connected to computer or removed from it at any time. However, USB-based devices should be carefully plugged out from the computer, otherwise, you may lose useful information or corrupt the devices. First, successfully close all the applications related to USB-based device to be plugged out, then click on icon meant for safely remove hardware. Note clear in the notification area of the taskbar of the window. Operating system. You will get a dialog window. Select device which you want to disconnect by clicking over its name from the list and then press the stop button in the dialog window. Soon, you will get a message window to remove that device. Now, you can safely remove that device. 1.8 Classification of computer. Computers are generally classified by its physical size and efficiency of doing calculation. The work efficiency and size of computer are interdependent parameters. Computers which perform calculations at high speed are naturally bulky in size. 1.8.1 Mainframe computer. Mainframe computer are powerful computer capable of processing multiple tasks at a time. Arrays of microprocessors and memory units are placed in almirah-size cabinets in the mainframe for executing multiple tasks efficiently. A mainframe computer occupies space equivalent to a big-size room. Mainframes are powerful computer used by large organizations. These systems can be used by 100 to 1,000 users at a time. The first mainframe computer was designed in the 1944 by IBM, named as the Automatic Sequence Controlled Calculator. Users share mainframe computer on time-sharing base. Every user is allotted a fixed time slot on rotation basis. These time slots are so frequent that each user feels that he/she is using the computer solely. IBM Z series, System Z9 and System Z10 are the latest notable mainframe computers. More than 90% market of the mainframe computers is captured by the IBM. 1.8.2 Mini-frame computer. Miniframe computer are mid-size and multi-users computer. Its work efficiency is lesser than mainframe computers. A miniframe computer can support the computation needs of about 300 users. The computation power and cost of miniframe computer are in between microcomputer and mainframe computer. Spark, Power and Itanium are the popular miniframe computer manufactured by Sun Microsystem, IBM and Hewlett-Packard. The demarcation between mainframe and mini-frame computers is not very rigid, particularly when you compare a low-scale mainframe with high-scale miniframe computer. Miniframe and mainframe computers were developed when electronic devices were very expensive and resources were scarce. Users were forced to share resources with others. Operations and management styles of organizations at that time were highly centralized. Computation need of offices could be met with the help of centralized powerful computers such as mainframe and mini-frame computers. These computers offered most appropriate computation solutions at that time. 1.8.3 microcomputer. The term microcomputer is self-explanatory. These computers are based on single microprocessor chip. These computers are lightweight, compact, and have low computation power. Microcomputer is used in single-user mode, i.e., only one person can work at a time over the computer. Now, microcomputer is most common computer used in offices, schools and homes. Microcomputer may be in the form of laptop, notebook, desktop, palmtop and programmable calculator. Microcomputer with high storage capacity and execution power is known as workstation. 1.8.4 Workstation. Workstations are powerful machines used in single-user mode. They have high processing speed and large storage capacity. Workstations are usually used to facilitate and control computer network. They are at the center of the computer network. A computer network can be defined as an electronic communication network connecting computers which are members of a group with a prime aim to facilitate exchange of information. Workstations are mainly used to control computer network operationalizes in small areas. Such networks are termed as local area network, LAN. Workstation ensures efficient and secure transfer of data among computers connected through the LAN. Computer network is explained in detail in the fourth block. Workstations are also being used to perform complex computations, run simulations and highly graphic and multimedia-based utilities. Workstations are frequently used to perform complicated calculations in researches, scientific and engineering organizations. 1.8.5 Supercomputer. Supercomputer is the most powerful computer of the current time. An array of microprocessors and memory units works in parallel to execute multiple tasks in a supercomputer. Microprocessors and memory units in arrays may be situated at one place very close to each other, or they may be scattered in large geographic areas. The operating system manages transition across microprocessors and controls operations of individual microprocessor and memory unit. User never came to know which microprocessor has been executing his her tasks. These computers adapt special techniques and procedures to perform calculations. Each task is subdivided into subtasks, which are executed in parallel on different computers or microprocessors. In the final stage of the calculation, supercomputer collects outcomes of all the subtasks, merges and gets the final result. Thus, complicated computations can be performed at very high speed over the supercomputer. The first supercomputer was designed in 1960 by Sigmund Cray at the Control Data Corporation. Cray Research. The Cray, IBM and Hewlett-Packard companies are involved in the manufacturing of supercomputers. The Cray XT5 Jaguar system at the National Center for Computational Sciences is the fastest supercomputer of today. It consists of 19,000 computers and 2 to 4000 processing elements. The supercomputers are mainly used to forecast weather, run simulations, solve problems of science, engineering and research. 1.8.6 Personal computer. Personal computers are used frequently in mid and small scales offices, schools and homes. This is a small and single-user computer based on one microprocessor. Its short form IPC is more popular than its full name. PCs have relatively low computation power and economical computers. PCs are classified into two categories, i.e. IBM-compatible and Macintosh-compatible PCs. This classification is named after prominent suppliers of PCs across the world. The first personal computer IBM 5100 was launched by the IBM in 1975. It could not get commercial success as it was very expensive. The first PC cost was up to $20,000 US dollar. The first PC was based on Intel 8088 microprocessor. PCs have tremendous growth since then. PCs are also popularly known as desktop computers as it can be placed on the desk of users. Later, PC size further reduced and took the shape of laptop and palm top. Names of laptop and palm top reflect their size. The laptop computer can be placed on lap and palm top at palm of users. People can carry and use laptop and palm top during journey. They operate on lightweight lithium batteries. The latest PCs available in the market are based on the Pentium 4 microprocessor, manufactured by the Intel Corporation. The maximum speed of this microprocessor is 3.8 GHz. PCs available in current time are more powerful than mini computers available in 1970s. 1.9 generations of computers, the earliest electronic computers were made of vacuum tubes. Computers designed with vacuum tubes were classified as the first generation computer, 1944 to 59. The computers of the first generation were bulky in size, consumed lot of power and generate excessive heat. It occupied space equivalent to room. With advancement of technology, vacuum tubes were replaced with transistors. Computers became smaller, consumed lesser power, and generated lesser heat when designed with transistors. These computers were recognized as the second generation of computer, 1959 to 64. Later, transistors were replaced with silicon chips. The silicon chips are popularly known as integrated circuits, ICs. Uses of ICs in the manufacturing of computers led to the third generation of computers, 1964 to 75. Computers of the third generation became smaller, more powerful and consumed lesser power. Later, density of IC was improved, more electronic circuits could be placed in small area. This improvement in density of electronic circuits of ICs brought a new generation of ICs named as large-scale integrated circuits, LSIs. Uses of LSIs brought the fourth generation of computer, 1975 to 85. Computers became further, smaller, faster and powerful with the usage of LSIs. The uses of LSIs also improved the reliability of computers. The production of PC was the main achievement of the fourth generation. One of the milestones in the electronic industry is the development of very large-scale integrated chip, VLSIs. These chips are very dense. It also reduced cost of electronic devices, their size and power consumption. The computers based on VLSIs are referred as the fifth generation computer. This is the latest generation of computer. Computers of this generation are intelligent products, have high computation speed and large storage space. The fifth generation computers are capable of accepting inputs in natural language from human generations of computers are relative terms. You may get slight variation in the definitions and characteristic of generations of computers in different books sources. 1.10 Computer of future computers will be more compact, lightweight, powerful and intelligent in future. Desktop computer will be replaced with laptops and palm tops. People can carry these computers during traveling and remain connected with home, office and friends through electronic network. Means of inputting and outputting signals and data to computer will be more versatile and fast. Keyboard and mouse in public kiosks will be replaced with touch screen input devices. Input devices can take information from user through cues and natural language. Users can input information under virtual reality in natural and expressive ways. Input device sends the movement of hand, head, eyes and feet. The ultimate goal of input devices is to get inputs from neurons, blood pressure, heart rates and respiration rates or any other body's transducers of users. The cost of computer will go down further with improvement in the density of IC. Low cost of computer will discourage the sharing of computer with others. computers will be more personalized. Computers will be connected with strong and reliable networks so that employees and society are closely networked and can participate in collaborative works in more fruitful way. 1.11 Summary: Computer is an electronic machine which execute pre-recorded sets of instructions. The pre-recorded sets of instruction are known as programs. Alan Turing is widely recognized as the father of modern computer. Computer functions on binary number system. The radix of the binary number system is 2. ASCII and EBCDIC code specifications are used to code alphabets, numbers and special symbols into the binary form. The organization of computer consists of 4 main components, i.e., input, output, processing, and memory units. Input unit is used for inputting data and instructions to computer. Processing unit analyzes and processes data and execute instructions directed by users. Output unit convey information from computer to outside world. Microprocessor is the brain of computer. Pentium 4 is the latest and most popular microprocessor manufactured by the Intel Corporation. Memory is used to store programs, instruction and data. Memory is classified as primary and secondary memory. Computers are classified as mainframe, miniframe, microcomputer, workstation and supercomputer based on work efficiency. Thank you. Subscribe to our channel for more updates, and we will see you with the next chapter.